Okay, so students, last class we discussed the basics of geometric transformations, and then we saw the scaling of images, that is the shrinking and the zooming of images, and we saw its practical application using the resize function, and we also saw the concepts on interpolation. Next thing we will see today is translation. Now, translation in general, normally, what does it mean in English? Translation normally means you transform, for example, English to Arabic, you transform one representation into another representation. So translation is not only for languages, it can have many meanings. So for example, you have an idea in your brain, you translate it into something physical, you create some project. Okay, so that is also translation. And one meaning is the traditional meaning, you translate a sentence from English to French or Arabic, so that's translation. There is one more in the context of images over here. The translation means, so get the pen. So translation over here means that you take the image and on the XY plane, so let's say your image is in this quadrant. So your image basically at the beginning it starts with 0 0 over here, and you move this image to another part of the screen. Okay, so you move it to another position. Okay, so this your image starts over here, which is the position 0 0. Maybe you move it to another location, maybe 10 comma 10. Okay, so translation is basically the shifting of objects location. And what you will do is that if we know the shift in x and y direction, let's say you say that the shift is t x and ty, then you will be adding the t x and y values in the original value. So original value was 0 0, now it will become tx ty. So tx and ty in this case are 10 and 10. So if you know these values, how much you want to shift in x direction and y direction. So remember, translation can only occur, movement can only occur in two directions, like this, and the second will be like this. Okay, x and y. So these are the two coefficients over here that are given that you will specify. This will be your transformation matrix for translation. How it will work? Here it is, the function. In matrix in CV, so in OpenCV, we will be now using the first type of functions. If you remember, if you go back, we discussed at the start that we will be using two types of functions for most of the geometric operations: warp affine and warp perspective. And other than the first type of transformation, which was shrinking or zooming, for all others we will be using these two functions. So warp affine, you can say that these two functions, they are similar. So I will not say exact, similar to what was the name of that function we used to apply the kernels? It was filter 2D. Okay, so they are doing same thing like filter 2D. What was the job of filter 2D, if you remember? Take the image. Okay, so take the image, what happened? So take the image, what is happening? And the second coefficient is -1, and then the third one is your kernel k. So you filter 2D was just performing the correlation of k and image. Same thing is happening over here. The warp affine and warp perspective, what they do is they take the given function and they apply it on your image. So this is your image, this is the transformation matrix. Okay, so this M over here, it is this matrix. And then also you specify the size of the uh, output image, how much size you want over here for the output. Okay, so M is your transformation matrix, and it will be in the format of floating point format. So that's their requirement, that M should be, even if the numbers are like in matrices, but it should be of the type float. So for example, in matrices you have numbers like this 1 2. So in this matrix it should be 1.0 and 2.0. This is their requirement. So just you will convert your integer matrices into float. So warp affine function, you will pass the matrix to the warp affine function as a numpy array of type np float. So numpy we will be using here, and we will provide it the matrix as float 32. Float 32 means it's a 32-bit float number. All of you know what is 32-bit or 62-bit numbers that we define in the programming languages. So here it is. Practically, if you saw the in the initial there were only 2 rows, but there are practically 3 rows. There is third one also, which is our you can say dummy row. It's not practically used, but they put it like this. Okay, just to make it a square matrix. Okay, so here it is. Now again, if you do the multiplication, so row is multiplied by the column. So how it will work? X will be multiplied by 1, y with 0, and 1 with tx. So practically it will become x prime equal to x plus tx, y prime equal to y plus ty, and 1 will be same. So whatever was the location of, what does this equation mean? It means that if the original location of x was 0 and the displacement that I want to do is 10, the new location will be x prime will be equal to this much 10, and then y prime will be 0 plus 10, it will be also 10, where this 10 is basically the movement that you want to perform on the image, how much you want it to move. One thing is very important that you see over here below, this is very important you remember for your exams also, is the different type of transformations that we will see throughout this chapter. What are their properties? So the property of this transformation in the translation is that it preserves. Preserves means saves, or you can say do not destroy orientation. Orientation means angle, rotation. So if you move the image in x direction or y direction anywhere, the rotation of the image is not changed. No change in rotation. Okay, the image is not rotated. If it was straight, it will remain straight. It was tilted, it will remain tilted. So that's important point. Translation, exam question, translation preserves dash, and dash means over here orientation. Clear? So this is translation. So this time we will be going through the examples closely. So let's go to the lab work now. So here it is, the translation part. So we saw last time for the shrinking and zooming scaling, we did this exercise. Your part of the exercise is you will shrink and zoom the image, both shrink, zoom the image, and the image will be the Brooklyn Bridge. Okay, Brooklyn Bridge image. So it is Brooklyn Bridge, I think, .png. So this you have to remember, this image you will use for shrinking and then you will use it for zooming. Same image you will use over here also for your practice of translation. So here is the translation. Translation is basically, again I repeat, shifting of object's location. So if you know the shift, the value of the shift you want to perform, tx and ty, then the translation will be like this. So you can create this transformation matrix like this. So remember, the matrix should be of np float 32. So here it is what we make. So this thing I will change in the slides. So you don't need the last column. This one is not needed. I think they have put it just as a dummy row. So you don't need this last row. Practically it's not needed here. This is the one that's needed over here practically. So let's say you have this image lena.jpg, lena original.png, and you want to shift it 100 in x direction and 50 in y direction. So how it will work? So let me load it. So here it is. Then what I do is that I create this matrix. So this is a 3 by 2 matrix. So you see 1, 0 and 100. So here 1 means this is x, and 1 dot means this is a floating point number. 0 dot, 100 dot, all of these are with dot, means they are floating point numbers, they are float. Remember, I think if you don't provide float, it will give you error. Okay. So the second row will be 0, 1. So 1 is this time for the y column. If you swap these values, it will make a big mistake. Okay. This first should be for x, second should be for y. The diagonal values will be 1, like in an identity matrix. Okay. So you perform this, and then the third value over here is 50. Clear? So what we do over here is we have taken these values of rows and columns. What's the purpose for taking these values? They are to be used with as the output. So let me print them, rows, columns. Okay, so here it is. The original image, from its shape argument, we take how much is the size of the image. The original, this image has 537 multiplied by 514 pixels. Okay, so these values we take from there and we just put it over here for the output. So what it means is that we don't change the output size. Okay, and if you see what happened, the image has been moved 100 in x direction and 50 in y direction, and you will see definitely, because you did not change the image size, now the image has cropped, it has lost the data from the sides because some of the image could not fit in this area that you provided. Clear? Now this is very important point to remember. If you want, maybe you can try, for example, to increase the size of the output, and then you see over here, now the image is complete. You have but moved it a lot. Okay, so I can increase this movement. For example, if this was 100, maybe I increase it 300, and the top to down, how much? So let's say the total size they have given is 1000, and I want to move it. So I should move it, I think 200 or 300. 300 is okay. Same over here also, 300. So let's try. So here you see it has moved. 300 is too much. 250. So almost I have moved it in the middle. But if I hadn't given this argument, or the argument value was same as before, then the whole image would have, almost the whole image would have been removed or deleted. Okay. So this is what has happened over here. This is important thing. Sometimes you want to cut the image or you want to move it, and this is the thing, you can do it practically yourself. Okay. So now this is your job, that you will load the Brooklyn image, and you will move it to the left side, to the right side, sorry, such that only this much image is visible, this much. Okay, the first pillar of the bridge is visible and the portion before that. The portion after, or let's say, no, do the opposite. The bridge should be visible from the first bridge to the second bridge, the main part of the bridge. Okay, the remaining you should cut it. Now how you can move the image to the opposite side? For that you will do the minus. It's given here also, the exercise. You move the image in minus direction. You will not do this task. You will do the one that I gave you for the Brooklyn. Move to the left side. So how the movement can occur to the left side? Just put a minus. You see, it has moved to the minus side. And what does it mean, moving to the minus? Now your image starts somewhere over here on the in the other quadrant, in the other box, in the other region out of those 4 regions of the geometric plane. So it starts somewhere in the other region. So here you see hardly a little bit portion from this area. Clear? So this is your exercise, and remember you have to submit these things for your marks once you come back. The assignment for this thing over here is move this is the same image you will use above, shrinking and zooming also, and here also move the Brooklyn bridge.png image such that area between first and second pillars are visible only. Okay, this you have to perform. This is your task for this lab work. Now moving to the next one is the rotation. So remember, translation, it preserves orientation. Next one that comes is rotation. What is rotation? Rotation means I have an image and I will change its angle, or the best word used is orientation. In the previous topic you saw orientation is preserved. That's the same orientation we discuss here. So you have an image like this and you rotate it such that, for example, like this, it is tilted. So rotation of an image for an angle theta is achieved by transformation, by the transformation matrix of this form. So if this is your image, for example, okay, and we will discuss how we calculate the theta. So theta is the angle of rotation, then this will define your matrix, rotation matrix. So you are using now the common functions, trigonometric functions, cos theta and sin theta. All of you know what it is. So here you will use diagonal, it will be same value, cos theta, and on the opposite side of the diagonals you will use minus sin theta and sin theta. So this will define your transformation matrix. Here it is shown. So this was not complete, partial. Here let me show you how it works over there. So rotation, so I forgot before, we will not use affine matrix, warp affine for this. For performing the rotation, you will perform the rotation using, and let's go to the lab side and then I will show you. So to perform the rotation, you will have, so let's say you have this dolphin image, you will use the same warp affine, okay, but before doing the warp, so warp affine has, remember, it has 3 inputs: image, transformation matrix, and the output size. Okay, now the confusing part here is that the M, the transformation matrix, it's not easy to create it. It's this matrix over here. So for this purpose, CV2 provides another function. It is called get rotation matrix 2D. Okay. Now you can ask me why it is not easy to perform this rotation. It is based on two things. Remember, get rotation matrix, the input arguments are not given. It has got three arguments. One of them is the center of the rotation axis, the rotation angle. I don't remember what is this. I think this is the minimum unit. Again, if you forget something, it's very common. You will go and check the documentation. So I wanted to check what is this third argument exactly. If you have ever some confusion, make sure that you check the documentation. So here it is, get rotation matrix 2D, center, angle and scale. Yeah, so I was right. First argument you will provide the center. So center you will provide x and y. So you will provide it as a in the brackets. Okay. Angle, it provides you will provide the rotation angle in degrees. Remember, it's not radians, it is degrees, the normal degrees that you use in geometry normally. Okay. And positive values, they mean anti-clock, counterclockwise rotation. Okay, we will discuss this. And finally, the scale means how much is the minimum unit for your rotation. Okay, so practically the rotation that it calculates, it is calculated by this formula. You see this formula, and it's a complex thing. So that's why they have given you this function. You use this function directly, and you don't need to go into those details. So formula is given to you, formula is over there. We will not go into those details. What is alpha and beta? So alpha is basically same thing. How much you want to rotate, multiply by scaling. If you want to make it large also, large or small. While rotating, you want to make the image large or small. Together, alpha means scaling multiply by cos of theta. So that is the same thing shown over here to you, this one. If you don't perform scaling, it will be 1 multiplied by cos of theta. Okay. So same thing is here. The same thing is given here. And these are the four arguments. First argument, first column is this, alpha minus beta. Second column is beta and alpha. So remember, alpha and alpha are same, diagonal, cos theta. And these are sin theta. Okay, and the third argument is a long one that takes a lot of things that will define your rotation. That is one, how much you want to rotate it. So practically you don't need, for your exams, you don't need to remember this thing. You don't need to remember how much you are going to rotate. For exams, you just remember this one. Simple. Rotation and translation. That's enough. Okay, so whatever is in the slides, you remember it. Whatever is here in the lab notes, you don't need to memorize this formula at least. Other things you have to remember, but not this one. Okay, so in general, when I want to perform the rotation, so I will provide three things. What is the center of rotation? The rotation angle, how much I want to rotate, and what is the minimum unit, which is 1 in most cases. So let's say this is my image. Now if I want to rotate, I want to give the center of the image. Okay, center of rotation means what is the axis from where I want to rotate. For example, I put over here a pin, and then I pin the image and then I rotate it around that pin. Okay, so what happens is that in this case it will rotate around this center. So you see this difference over here. Let's say I change over here. Now a big question. Let's say I put the center at this location, what will happen? So if I can draw somewhere, mm, yes, here. So let's say this is my image. Okay. When I wanted to perform a rotation, rotation is normally done based on the center. Okay. So center point is here. So I perform this rotation based on center, and if I perform plus 90, it means anti-clockwise 90. So anti-clockwise 90 is opposite. So this is minus 90, sorry. Okay. So I created a minus 90 rotation. Okay. Minus 90. So remember, if a rotation is like this, just like in geometry you do, it is plus 90. If you do 90 degrees, this to this angle. But if you do rotation like this, it will be minus 90. So here, if the rotation center is the center of the image, it will be done like this. Now another very different case. Now this is serious. This is difficult. Rotation, if you consider this point as the rotation axis, what will happen? Now that's my question. What will happen if the rotation axis is that point? The whole image, for example, I do the rotation, the whole image will go outside the image area. Okay. So the image area is this area. Okay. And in the image area, there is nothing remains, and the whole image has gone above the image area. It is rotated. Okay. So just imagine that I put a pin over here on this point. I put a pin. It would have been better if I could show it with hands. That I put a pin over here, and when I put a pin at this point, then I move the image in this direction. So when I move it a little bit time after 90 degrees, what will happen? Whole of the image has gone outside the image area. So the area over here you see, this is your image area. Clear? So all the things are gone out of the image area. Now that is important point to understand. Whereas if your rotation, center of rotation was this one, in that case, when you do the rotation, image will always remain inside the image area. The image area is this, the visible area. When you do the rotation, unless the image sides are different, for example, image width is more and height is less. For example, if your image is like this, very long, very wide, but very less in height, then after rotation, what will happen? It will become cut. A small part will be displayed over here in the center, and most of it will be cut. It will be outside the image area. I hope I can explain it. I have explained it properly. I don't know. Okay. So I will give you now examples. And if this thing confuses you, you will now see the example. If still it confuses you, please ask me, and then I will try to do something else to explain it. Okay. So here it is. If I perform the rotation, it is the dolphin mouth was on the right side. Now it went to the top. So it is the 90-degree rotation. Now if I do minus 90, what does it mean? Minus 90 means here it goes down. It was on right, it goes down. Now if I do the other thing that I explained to you, instead of this, I put over here 0, 0. The rotation center point I change. What will happen? So just imagine. All the things have gone outside the image area. Now the image is there, but image is being created over here, outside this area. I hope I am clear about this. So it's minus 90. So it will be below. Okay. all the things they have gone, and they have gone to this axis. Okay, so image was here. Let's say, so just imagine it is same as you put one finger on the side of the image. So I put a finger over here, and then I rotate the remaining image. So what will happen if you put a finger over here? So when I put a finger over here, one edge or one corner of the image is fixed, and the remaining whole image, I move it to clockwise, then the whole image will move to this side, the third region, third quadrant. When it moves over there, and if I move it enough, 90 degrees enough, then the whole image is gone outside the visible area. I hope it's clear. If I choose a little area movement, 45, then partially it will be moved. You see? Now half of it is moved, half of it is over there. I hope it's clear. This thing happened because my center of rotation is 0, 0, this point. But if I use the same old values as center of rotation, what happened? Yeah, if I use this value, what will happen? Now if I use minus 45, now the image is over there because I rotated when I put my finger in the center. Most of the image is there. If the image was a perfect square, then it would not have made any problems. A little bit of corners will have been cut in case of 45 degrees. Okay, but because the image is not a square, it's a rectangle, so a lot of things will be cut when you rotate it based on the center point. So if you move it 90 degrees, the extra side values will be gone. Now you see the image was before larger. Now the image, some part of the image is cut from here and here on the top and below. The center of the image decides what will happen. Is it clear? This is a difficult concept. Remember, rotation matrix, you will get it from this function by giving three inputs: center of rotation, or the axis of rotation, the rotation angle in degrees, and the unit, minimum unit of rotation. Okay, so this is it for the lecture, and I want you to perform this rotation task on this, I think, car image. Okay, so Frumer, it has a direction. So when you perform the rotations, you will check out and give me the rotation values. So rotate Frumer.png with these angles, center and angle values. So first of all, rotation center is this, or first of all, maybe you keep the natural one. The natural rotation center is the center of the image, mid and mid. X and Y values will be mid values of the image. Mid, how you calculate it? You will calculate it by this formula: columns by 2 and rows by 2. So mid value you will use it, and then you will provide the rotation of 45, 90, minus 45, minus 90, and then there will be some bigger values, 160 and 250. Okay, so here I will use the other one. Same thing you will perform when you rotate it using. Okay, so save it, keep an image for this, and you will perform this also. The whole task that you will do, it will be in the same Jupyter notebook. I will check it after the exams. Ignore this instruction. This is not for you people. You will perform this one. These rotations you will perform here. Use one separate cell for each type of rotation, and don't forget to put headings. If you don't put comments for the rotation and the center point of rotation, it's bad. Okay, so this is your task for the rotation and for translation and also for shrinking of the image. You have to perform rotation. You will perform on the Frumer image, this one, and the other two tasks, translation and shrinking zooming, you will perform on the Brooklyn Bridge image. Okay, so I think this is enough. And next class we will go next, so after the rotation. So something is left, no. So after the rotation, next class we will go and discuss the final topics on the affine transformation and perspective transform. See you then.